one,
Yes.
but not same location.
Well, say it. This is important. That is important.
Yes,
Okay, maybe
if you
this
compare
is
these,
important.
if we compare these study, our results parallel to these ones, but the locations are different. So I don't.
How different?
Our locate the first cluster located at these
Yes.
direct, and the in this.
And how about the other one? There's another one who has proposed the same. There's another one who has proposed the same.
These.
No, the transverse fault.
Ah.
Yes. Atiloğlu has proposed
Yes.
the same transfer. Are they the same?
No.
Why don't they explain it? You should explain it. There are three proposals for the transverse fault. Atiloğlu, İşcan, and what we have to do. And they're slightly about 15 kilometers apart. They're all parallel, but slightly different. How about the east-west?
This one, maybe all of them. This and protocol, this one, and
Yeah, everybody has proposed.
I think there was some inconsistency between the good result and the your results, as I am seeing in your conclusion. Some vertical fault or something they are proposing.
I only said that the cluster 3 is located at this, but this part is not same.
And if you put together to show your conclusion, it's written on of them, it's written in your conclusion. Also there is three new segmentation, I think. You have observed.
Yes, yes, in the this part.
There is one thing that doesn't appear in the thesis. Maybe you should give this information as well. An interesting thing about default plane solutions.
Yes, I done the fault line solution. Most of it reverse, but they are not checked by my advisor. So in this case,
Reverse.
Well, she observes some fault plane solution in that one. And she got reverse.
Not all reverse.
No.
Yes.
Where else in
So
the
they are
past?
not in much.
Where else in the past? Everybody who did fault plane solution, they found normal, including me. So this is something that needs to be looked. But there is one interesting thing about reverse fault, say that as well. Somebody else has found reverse fault.
Yes, it's John et al. In 2000.
Ben mi hatırlasın böyle? Söylüyor Allah. Okay. Yeah, say again, this is interesting. İşcan has found
Yes,
reverse
the
fault
reverse fault in
on the
this
eastern
section.
part of
And my
Which
last
part? Can you
question.
show with your hand where the reverse fault is? That part, okay.
And maybe the results, the orientation is that, but my results the reverse.
Okay.
And that's object.
What's the depth of this hole?
And in this case, almost 20 kilometer the depth distribution of the emerging depth.
And you
This
say
was-
this information comes
In-
from
in
the
this-
class formation.
No, not this one. This one comes from
The size of
Greece.
my
Bir yarışma. 2 kilometre, 5 kilometre. Is it possible to compare the
not
result with the sense of-
take into account the depth.
So first of all, how do you define a cluster?
According to the okay, distribution, but I tried many other options.
Can you show me one of your maps with the clusters, like you know what to define as clusters?
The clusters, but in this case, it's not. It's almost exactly cluster 3. I used the FMF and the cluster this thing in this terminal is okay there.
So by defining clusters, does it bias the program in any way, or it doesn't? Because I
After
mean,
the clustering, I combined these two clusters and the other 3 ones. all the data is not useful for
So,
the orientation.
but from what I understand, whether you define a cluster or not, actually, this double difference works with, like, you know, it calculates neighboring points and then moves it to the next point and then moves. So, whether you define like 10 or 2 or 15 or 1, would it make much difference?
According to the distance.
I mean, you know, why would, what's the point of defining clusters? I'm trying to understand, like, you know, I mean, how do you decide? Like, one of them is really big, one of them is small, the other one is big, you know. So what's the criterion here? So like definition of a cluster.
Only the distribution, and I tried the other options and maybe and the previous in my thesis it was only that location.
So does it change anything?
No, because most in this case, for example, most of the earthquakes are located at the distance of the according to our parameters, the axial parameters. Most of them eliminated because the distance between the earthquakes, for example, in this case, is relatively small.
So another question is, you know, when you use it, I'm not very familiar with this, but you know, when you do the correlation, if the mechanism isn't the same, because I realize it looks like it's a very complex region, you know, because if you have a vertical fault, you know, you would think that it would be partly strikes with to some degree, because I doubt that, you know, there are many like thrust or normal faults with 90-degree dip, but you know, I mean, it would be very hard to have a 90-degree in thrust fault. I can't think of it, but so if the mechanism is different, how would it reflect in your results? Would you be able to filter it out completely, or would you be able to sort of like miscalculate because of the mechanism?
I didn't try it. Yeah.
Because that might be a very key point in the correlation study. Because it looks like such a complex region. And since the orientation, even if the same mechanism, if just the orientation, let's say you change the strike, that's enough. The whole waveform amplitudes will change. And sometimes the polarity, which might turn into time shifts. You know, I don't know if it happens, but it might easily happen. Like, you know, if you have a 35-degree change in strike, you could have an up polarity and down polarity, very easily. And also, another thing is, like, what's the correlation length? How do you choose the correlation?
For seconds between the P and S phases, the 2 seconds before and after are the cut.
So 2 seconds before P to 4 seconds after P, or 2 seconds after P. So total of 4, 2 before and 2 after. Okay. So do you think that is good number, like 2 before, 2 after?
At the end, we run the program but before we optimize it, I tried many options, meaning I control our waveforms, but at the end we run it automatically, so maybe it should be details.
Because if you include too much, you know, of course, the structural similarity will show up as high correlation, because they are so close by. Even, you know, they are not very similar. I'm not sure, like mechanism-wise. You will still see. So because I'm thinking about the mechanism. Like if you have a different mechanism, would you still have high correlation? That's what I'm thinking about. That's why, you know, something to play with might be so that, you know, you only have the first. Sort of like whether it's the up and amplitude or like, you know, how it starts, and then rest, just kill it off, you know, like don't even include it because it's probably some sort of reverberation, like multiples, whatever. So it might be a problem. I'm not sure. I think, you know, it's of course very safe to do the just time picking itself. It's, you know, but the other one, of course, needs much more things to think about. So. Let me ask some other questions. What's a nonlinear problem? You said the problem is nonlinear.
The effects of the Earth's because of the complex.
So for example, if earthquake location, let's assume the Earth was a half space, constant velocity, would it be a linear problem in that case?
Earthquake.
So for example, you calculate the travel time from a point at some place and at the station, non-linear.
Not.
It's non-linear. So it's not just the complexity of the structure, right? So why is it non-linear?
Because of the Earth structure, the ray is not linearly.
No, in half space it is linear. It just goes straight. It's just a constant velocity. Here is an earthquake. Here is the station.
In this case, it should be linear.
It should be linear.
What is linear and what is non? That was the original question. What is linear? How can you decide if something is linear or not?
Can you write a travel time on, let's say, just a simple thing, constant velocity. You have an earthquake somewhere and you have a station. Can you write a travel time formula for the travel time?
The earthquakes on the station.
It's straight, so it's constantly. Yeah. Okay.
The distance and the if you look at the
Yeah, do it in 2D. You have x and y, z. You have x and z, and of course the origin time.
X.
Okay. But you also have y, z. So the total distance is what? Plus some origin time. Okay, so the dependence on origin time is linear, but it's non-linear in terms of x and y because if you look at this one, okay, let's move on. So what is correlation?
Yeah. In the couple of data, we compare